Ladies and gentlemen, good evening, good morning, good night, wherever you are. This is the last session of our conference, the closing session. And it's the closing session of a great conference. But it is not, it's not a, sorry, yeah, I have to go full screen, sorry. Yeah, sorry. So it's not difficult to make a great conference if you have great science results. And indeed, we do have great science results from the last 2 years. There was very good progress despite the difficult situation in which we have been living over the past 1.5 years. And also, it's good if you have many persons who are involved in planning and preparation, in producing, viewing, discussing the results, in managing the realization of the conference. And we did have such helpers. We had 250 people in LOC-C4, in the Ispc, and with the conveners and the speakers. We did have 1,300 contributions, which were sent to us from the community. We had exhibitors, and of course, we had 1,800 participants who wanted to see the various contributions and materials. And we had a conference and technical team of about 70 persons. So the conference was a real community event. Here is the short agenda of what we want to do now. I'll give you a short summary. We then have the Best Contribution Awards being moderated by David Berge, and we end with Sunil Gupta making announcements from C4. So at this Icrc, we had 1,800 registered participants from 55 countries. This is great. It's covering almost all the Earth, with a big gap in Africa, of course. And indeed, I repeat what I said at the opening, over cosmic ray physics and astroparticle physics, the sun doesn't set. We have had 10 reviews, 32 highlight talks, 9 rapporteurs talks, 57 topical discussion sessions, and 1,300 contributed talks and posters. In total, this is 300 hours of video, of recorded talks, slides and posters, all on an extensive archive that has 1.5 terabyte in volume. In parallel, we have about 12,000 pages of proceedings papers. This archive stays alive for conference attendance until the end of this year with all its functionality. Beyond that, it will be accessible for all in a slightly different form and at least to the next Icrc. Please use this archive. It has a big value, and it would be a waste if it's sitting there without being used for teaching, for research, for reading on what has been presented and uploaded here. We decided in November 2020 to make the conference totally virtual, and we could charge a fee as little as 130 euros. This is participation plus 1 contribution. That's about the average fee people paid. We had more than 1,800 registered participants. This is more than 100% on top of what was last time. 55 countries, 40% up, and 1,300 contributions, which is 23% up. This is due to the convenience of taking part in a virtual conference and has repercussions, of course. Here you see our dashboard of the conference system, and you see 1,481 items have been stored in the conference system. This is the contributions, the plenary talks, the exhibition projects, and all that. And 1,809 persons have been registered here. The user logins as a function of time. You see here in week 1, we started with a peak at the opening. The logins to the system then declined a little bit. This decline has also to do that we distributed the direct access to Zoom so that people could bypass the conference platform and still see the contributions. Here are the media views, and you see also there we do have a sort of decline, a fatigue after 3 days or so, but still every day and even in the weekends, more than 1,000 accesses to conference materials have been registered. Here you see the views per sessions, the attendance per session. For the plenary sessions, we had an average over 445 persons attending on average over the 2 weeks, which is a very good attendance. The new feature was the discussion sessions on topical physical topics, 57 in total, organized and guided by 2 to 3 conveners each. This was a great thing because the topics were chosen well and the conveners prepared what to do in these sessions very well. So also here we had a good attendance and a good turnout and a general appreciation of this format. Also in the discussion sessions, of which we had usually 4 or 5 in parallel, we clocked up participations between 400 and 700 participants. Now, the contributions were a bit complicated this time. As in the past, they were divided in talks and posters by the science program committee. In total, this time, we had about the same number of talks and posters, whereas in the past, it was always a factor of 2 times more posters than talks. But then there was a second distinction. Those contributions that fitted one of the 57 discussion topics were invited to take part in these discussion sessions. And that was in total here, the dark blue range on the top. Those that didn't fit so well to the discussion topics were presented in the presenter forum, a sort of digital small group meeting, like kind of a poster session in the past. This was probably not perfectly well communicated. Many had the feeling that even though they had given a talk, they were demoted to a poster session, but that was not meant like that. And the presenter forum worked relatively well. Every contribution had a table at which the contribution was supposed to be presented, and people were supposed to come. We had 5 buildings in total, halls for the different subject areas. Each hall had 9 floors, so enough space for all the 540 contributions that were supposed to go in the presenter forum. Now here you see the attendance, and unfortunately the attendance was not terribly good. We had expected that the 540 presenters would be present. And then on top of that, that maybe 500 other participants of the conference would come and visit these presentations. But overall, we had on Friday evening only 624 persons being around, and on Monday even only 455. So many presenters did not show up and very few visitors attended. Technically, there was no problem, but this outcome was kind of a disappointment to us. So future organizers NC4 will have to discuss and think how to modify the concept so that there's more contentment between those presenting and those who come and visit them. Let's go on to the proceedings. The proceedings were done with the well-proven system from POSISA. Here is the link where already you have open access to all the contributions that have been uploaded. Alexander Kappes from Münster and Bianca Keilhauer did a courageous job battling all the mails, thousands of mails they got about the uploads, about modifications, about how to deal with author lists and so forth, but they managed that very well. At this point, a reminder, you can upgrade your contribution till 31st of July for normal contributions. For the plenary speakers, we expect your papers by 15th of September. Then shortly after, the system will be frozen and will be publicly available for future. The situation is quite good. Already now, 96% of the contributions that we expect are there. 49 plenary talks are still due. So we expect that all those will be coming. So we have, in the moment, only 7% missing, and maybe some of those show up as well by the deadline. So this is a very good result, and all these papers will be a great record of the conference. We did have fringe meetings aside the conference on various topics. Industry and science fairs have been organized by Andreas Haunks and Katrin Link from KIT. The turn-up was not so great. We had expected more, but those that came had interesting stuff to show. For careers, we offered 3 things: a writing course, how to write a scientific paper, which was limited to 60 persons. It was booked out very quickly, and we had participants from 36 countries. Speed date of a recently tenured physicist, also that found great interest. Postdocs and students could find out what it takes to be successful nowadays in science. Laura Fabietti from Munich has organized that, and both were great successes. The job board was put up by Jakob van Santen. We got 31 adverts of postdoc positions, faculty positions, adverts for seeking a post. So we hope that many found each other and could offer us and seek us and could talk to each other, and maybe a formal application is following. On diversity, we had an interactive video project organized by Summer Plot. She has collected inputs, but is still finishing her project only with a few more inputs. So here is her advert poster, which you have seen in the breaks already. It's still open. Please have a look again and perhaps send a page for you to take part in that. There was a show to picture a scientist. 200 persons chose to watch this movie about diversity and structural disadvantaging of women in American university system, but the documentary was award-winning, and it's, of course, the problem is not only limited to the United States. So those who saw the movie had a discussion, and the outcome of this discussion was that we want to push the sensitivity for that object, of this topic in future in all the countries. There was sustainability in astroparticle physics, talks and panel discussions on green computing, green experiment, conferences and travel, organized by Markus Roth and Uli Katz and Stefan Funk from Erlangen. And we had a good turnout, almost 200 persons participated in that. And for many, it was a revelation, an eye-opener, somebody commented. It made many people reflect about their own behavior, their institutes and experiments actions. And with respect to CO2 consumption, for instance, it was a very impressive number that Victoria Greenberg quoted. A large international online conference reduces the footprint of such a conference by 99% by being online. So in this slide, people will start thinking. A first seed had been planted. So maybe we will see some changes in our behavior, how we make our research, and how we travel. And then finally, there was the Hess lecture for the wider public held in Germany. Werner Hofmann gave a very beautiful talk. We had about 150 participants. It's very well worth watching that, and it sits, of course, on YouTube and on our conference platform. Now, let's come to the part where we have to thank all the people who have helped organizing and running this conference. There's first the technical supporters. They are from Locke institutes in Germany. They helped partly from being at home, partly from being here at DESY. And in total, they worked about 1,200 working hours in the past 3 weeks. This slide looks crowded because we have put the pictures close together, but here in the background, you see that our helpers were sitting at safe distances. Of course, we took our Corona measures very seriously, and everybody who came here to the mission control at DESY was testing himself every morning and was wearing masks when moving around. Here is a DESY conference team. We had great help from a team of DESY in Hamburg to run our platform, Sarah and Oliver for WIMP, Katharina and Matthias for Remo. Then we had the core team here at DESY with Ulrike, myself, Axel, Silvia, David, Julia, and now Daniel, and I can't see, part of my screen here is blocked, so I forgot now who the last person is in the row. And below here you see Nicolas and Leah, who have been running the plenary sessions, and Nicolas and Leah helped us for weeks before the conference to set all that up, to register you on Indico and so forth. Here, some pictures of DESY infrastructure we have used from the technical infrastructure department, from the computing center, the administration, the event management, and communication and secretary services. And here's some impressions, how things looked when we did our recordings, when we had our morning briefings in the foyer, and just to give you an impression what kind of effort that was for us. Now here, my personal thank you goes, of course, to Julia. without her management skills and her keeping all the strings in hand and bossing us around, you know, that we have to be in time here and there, that we have meetings to talk about this and that, this conference would have been ending in utter chaos. I personally could not have done that. And so a really, really great thank you to you, Julia, for all you have done. Now, on behalf of the total log, of course, we have to thank as well the bodies that helped us. The Ispc, the discussion conveners, the UPUB C4 Commission, all contributing authors and all participants who use so skillfully our system without having problems with it. So it remains to say goodbye from us, the log. Thank you for your participation. Use the Icrc archive. What we can't say is have a good trip home, because you are already home. And it just remains to greet you from the Icrc Mission Control at DC in Zeuthen. Thank you very much. We pass on now to the second part of this closing session, and that is moderated by David Berge, and it's about the Best Contribution Awards.
Okay, thanks, Johannes, for this nice introduction. I hope you can hear and see me well. So I will be moderating and guide you through the best contribution contest of this Icrc. I want to start by saying that when we from the local organizing committee left the harbor to set sails to the beautiful virtual Icrc islands more than a year ago, it was very clear to us that there are great opportunities in a virtual event, and Johannes mentioned them, you know, CO2 footprint, number of attendees, numbers of contributions, and this is a fantastic advantage. However, we knew that there would be disadvantage. There is a certain Zoom or meeting fatigue that sets in after a couple of days. We all stay at home in our routine and perhaps don't participate as much as possible at all times in discussion sessions. So it was clear to us that, in particular for young scientists, it may not be ideal at all times, the amount of interactions you can have and the visibility we managed to create for you in such an event. And so we decided we wanted to try and address this a little bit, the visibility aspect, with a best contribution contest. And the way we did it and organized it was that all conference participants were invited to vote for the best contribution via the like buttons of each contribution on the conference platform. And my thanks go out to everyone who did that. And then in addition, we composed a jury that I chaired, composed of local organizers and members of the International Scientific Program Committee to make the final choice. And we chose 6 prize winners, 3 for posters, 3 for talks, from the most popular non-plenary contributions by young scientists. Yeah? So non-plenary young scientists is what we took into account to really address this point of visibility. And now, the conference platform is perhaps new for some of us. The like button, perhaps some people forgot. So we did realize after the fact that there were contributions that were viewed a lot, but in fact did not appear in this like button ranking. And so the jury has then decided to also award a special jury prize, like we do in the most famous film festivals, for example. We took the liberty and awarded one more prize for the most viewed contribution. And this most viewed contribution is one that I hope, I guess you share my view, is demonstrates a new kid on the block for us, Lasso. as it goes to Xiping Zhao from the LASSO collaboration for his measurement of very high energy diffuse gamma ray emission from the galactic plane with LASSO KM2A. And so what we'll do now is each prize winner will step through the main content of his or her contribution. For the posters, we'll play the videos and then show you the award certificate. So Xiping, please, you're the first one to speak.
Well, thank you, David. And hi, I'm Xiping, a PhD student from LASSO Collaboration, and these are my group members from PMO. We work together on this contribution together. And David, next. The next slide.
I did.
Yeah. Well, we know that the galactic diffuse gamma ray emission is a very important probe of cosmic propagation and interaction. But however, till now, there are only a few measurements of the diffuse emission in the very high energy band from experiments like Milagro, Argo, and most recently, the Tibet AS Gamma, which measured for the first time such diffuse emission above hundreds of TeV. So next.
Will come.
Okay. So we believe that the LASSO can significantly improve the measurements, and thanks to its large area and high sensitivity for gamma ray observations over hundreds of TeV. Using 1 year of the data collected by the half array of the KM2A, next.
Coming.
Of the KM2A, we give very preliminary measurements of the diffuse emission from the galactic plane for energies above 10 TeV. The top figure shows us the sky region of the analysis. The preliminary spectrum is shown in the bottom right figure, together with those previous measurements. And more detailed analysis, and especially the study of the systematic uncertainties, are ongoing. And we believe that it won't take us for too long to publish the final results. That's all. Thank you. Well, thank you. It's my great honor to receive the jury award for this contribution, and it's actually the honor of the whole LASSO collaboration. You know, without great efforts from all members from the collaboration, we can never have the chance to get this further. I also thank the attendees of the ICRC who encouraged me so much for their favor of my presentation, and thank the LOC for giving me this honor. Thank you all. Thank you.
Excellent, Xiping. Thanks a lot for this. Let me show you. Here's the, let's see if you can see that. Here's the award.
I can see that, David.
There's a mug.
I'm so excited.
There's a mug here, which you will receive in due time.
It's fascinating. Thank you.
Okay, so then we'll move on to the first winner of the best contribution for the best contributed talk prize. Poster prize, confusing myself. Tatjana Kozinets is a PhD student of Niels Bohr Institute, and she has contributed a poster entitled A Numerical Approach to Angular Distributions in Hadronic Cascades. Now, I want to say two more things. One is she was in the presenters forum. Yeah, so Johannes mentioned that we were struggling perhaps a bit with attendance there. So I'm very, very glad to see that actually the popularity contest plus the jury have also picked some contributions from this. And so for the poster contributors, we will actually play the videos, and then you will also see the prize winners live. And the reason is, as you'll see later, some of the videos were clearly chosen because they're fantastic videos. So I think it's also nice to see that there are great opportunities offered in virtual conferences by means of good videos, for example, that capture the content very well.
Hi, my name is Tatjana, and I'm a PhD student at the University of Copenhagen. I would like to tell you about our recent study on a numerical approach to angular distributions in hadronic cascades. Hadronic cascades are a central component of the cosmic ray air showers. The rich cascades of secondary particles induced by interactions and decays of hadrons in the atmosphere are quite widely spread at low energies. Therefore, to model the angular distributions of these low-energy secondaries, one needs to account for the full 3D evolution of a hadronic cascade. There are quite many Monte Carlo-based solutions for that. However, the highly sophisticated treatment of individual particle interactions in such codes comes with high computational costs. This study takes a different route and develops a numerical approach to angular distributions of order GeV cascade secondaries. To do that, we use MCQ, a state-of-the-art numerical software for particle cascade development in matter. As MCQ currently operates only in one dimension, so it solves for particle fluxes just as a function of the slant depth x, this study aims to extend MCQ from 1D to 2D by including the angular component. This is an important step towards fast and flexible modeling of, for example, low-energy atmospheric neutrino fluxes. Applying our approach to the development of a 100 GeV proton cascade in the Earth's atmosphere turns out to be quite successful. Here, we are comparing the angular distributions of the secondary muons from 2D MCQ and Corsica, which we used as the benchmark Monte Carlo. We find quite a good agreement between the two, and this conclusion extends to a wide range of altitudes and muon energies. This suggests that our tool can be a fast and accurate alternative to the Monte Carlo cascade development approaches. If you would like to know more about this study or have any questions, we're looking forward to seeing you at the Presenters Forum. Hi, my name is
Tatjana, well done. Your award and your mug are here, and you'll receive that very soon.
Thank you very much, David. Yes, hi everybody, and I'd like to say thanks once again to the whole local organizing committee and all the participants. It's really been a pleasure to be a part of this conference, and I hope that the tool that we have developed here will be useful for this whole community and will facilitate many more exciting studies in the next years. Thank you very much.
Thanks, well done. Moving on, the second award for best poster is given to Axel Donat, a postdoc by now at the Max Planck Institute for Nuclear Physics in Heidelberg, with for his poster contribution and video entitled Gamma Pi, a Python package for gamma ray astronomy. And the video is following now.
Gamma ray data analysis package.
Hi, and welcome to the virtual Gamma Pi poster. Gamma Pi is a community-developed open-source Python package for gamma ray astronomy. You can use it to analyze data from many existing instruments, including imaging atmospheric Cherenkov telescopes, such as HESS, MAGIC and VERITAS, water Cherenkov observatories, such as HAWK, as well as space-based observatories, such as the Fermi Large Area Telescope. Gamma Pi has also recently been selected as the official software for the CTA Science Tools. Installing Gamma Pi is very easy. Just download the Anaconda Python installation and download a predefined environment file from the Gamma Pi webpage. Now you can create the corresponding Gamma Pi Conda environment and activate it to get started with many tutorials to learn Gamma Pi or to run your first own analysis. Gamma Pi can be used as a normal Python package where you import functionality from the corresponding subpackages. But Gamma Pi also features a high-level interface which allows you to execute standard analysis workflows defined by a configuration file. Here you can see the results from two analysis examples that have used Gamma Pi. For the first one, we have used data from the Fermi Large Area Telescope to compute the S-maps for the galactic center region, taking the energy dependence of the point spread function into account. The second example is based on simulated CTA data and uses a classical reflected regions background estimation method to compute a spectrum for the galactic center point source. In addition, we've also computed flux points and corresponding likelihood profiles for multiple energy ranges. Of course, this is only a small part of the functionality that GammaPi provides. GammaPi is already used for many different interesting analyses, of which some are presented at this Icrc conference. We've listed the links at the lower right of the poster. You can also click on the links at the bottom of the poster to check out the GammaPi webpage and documentation, or to follow us on GitHub and Twitter. If you have more questions, you can reach us in the dedicated GammaPi Slack channel. Thanks for stopping by and see you soon.
Axel, congratulations. Here's your,
Thanks a lot, David.
your mug.
Thanks a lot, David. Yeah, what a nice surprise at the end of a nice conference. I mean, as the conference was purely virtual, we wanted to try something different, and I'm glad to see that it worked out in the end. And we could maybe, I don't know, possibly like deliver an experience of standing in front of a poster and presenting it. Of course, it was my face that was seen in the presentation and seen now. But GammaPi is really like a community developed package, and it's like a whole community of people working on open tools for astronomy. And I think all the thanks also goes to the group, and also, of course, thanks to the people that voted for us and that have checked out the contribution. So thanks again. Yeah, really glad.
Congratulations. Very well done to the whole team. Moving on, the next prize is the Best Poster Award for Thijs van Ede and Jordan Seneca, two PhD students of NICEF working on KM3net, and their video is fantastic and is another good example of what's possible these days if we can upload and store so many videos for such good posters. Enjoy.
We're standing here at the Ij in Amsterdam, where cosmic neutrinos are constantly pouring down, interacting in this water and producing lights. We want to know where these neutrinos come from, because, among other things, they can help us discover the origin of cosmic rays. We're building a neutrino detector, not here at the Ij, but at the bottom of the Mediterranean Sea. The detector is called KM3net. KM3net is already pretty good in finding the direction of events with a muon in them, track-like events. But there is unharvested potential in a different class of events called cascade events, without a muon in them. They're actually the most frequently occurring neutrino interaction, but it's more difficult to find their direction because the region of light production is more compressed.
So we set out to improve on this cascade reconstruction. And we did this in two ways. First, we made a more detailed model of the cascade events. And second, we included more information in the reconstruction, namely time information. Now we made two algorithms, one for single cascades and one for double cascades, which is a signature that can be produced by tau neutrinos. We tested the algorithms on simulated events, and we found that in both cases, we improve on previous algorithms and achieve a sub 1 degree resolution in direction. These results are promising, and they pave the way for all types of neutrinos to participate in neutrino astronomy.
My name is Thijs van Ede.
I'm Jordan Seneca.
And we are PhD candidates working at the NICEF Institute for the KM3net collaboration. Do you want to learn more about cascades? Please take a look at our poster.
There you go. Jordan, Thijs. Here are your awards, your mugs. Congratulations. Very well done.
Thank you so much, David. Yeah, so thanks for everyone. This was such a great surprise. So Tyson and myself are very thankful to get this prize. Obviously, we tried to do something a bit different for the presentation of the poster, and we're very happy that the jury and also all of you that watched and liked the poster seem to have enjoyed it, and I hope that you got something out of it as well, which was the point. Of course, all of this work does not come out of nowhere. We're building upon the work of our colleagues, and therefore we'd like to thank our supervisor, Art Heibor, our colleagues at our institute in NICEF, in the CAN3net group, and of course the rest of the CAN3net collaboration. Thank you.
Thank you very much.
Thank you. Well done. Moving on, we get to the prizes for the best contributed talks. The first one to be awarded is Eric Mayet, a postdoc at Wuppertal, for his work on indication of a mass-dependent anisotropy above 10 to the 18.7 electron volts in the hybrid data of the Pierre Auger Observatory. Yeah. And so since these videos were too long to show them entirely here, the best talk prize winners are given the opportunity to give a short speech about their content. Eric, please take it away.
Hi. Well, I'm honored to be able to give a brief overview of the results from this contribution I gave on behalf of the Pierre Auger collaboration. And in this work, we took 14 years of hybrid data measured at the Pierre Auger Observatory. Then we used it to compare the mean composition of cosmic rays coming from directions near to the galactic plane. And by near to the galactic plane, as you can see in this map at the top of the slide, we mean directions within 30 degrees of the plane. And then we compared the mean mass of these cosmic rays to cosmic rays arriving from further than 30 degrees away. So what we then did is we applied a minimum energy threshold of 10 to the 18.7 EV, and we looked at the mean Xmax that showers caused from cosmic rays coming from these two regions had. And what we found is that cosmic rays coming from the on-plane region had on average a 9.1 gram shallower Xmax than those coming from the off-plane region. And also, when we look at the distributions of Xmax, we found that the distribution caused by cosmic rays from the on-plane sample was 6 grams narrower. And these two together indicated really nicely that the cosmic rays coming from directions near the plane are on average a bit heavier than those coming from further away. Next slide, please. We also looked directly at the relative composition of cosmic rays as a function of arrival direction to kind of make a composition sky map. And you can see these here on the right. Both of these are the same map, the hybrid data above 10 to the 18.7 EV. At the top, it's in galactic coordinates, and in the bottom, equatorial coordinates. And here, the blue regions are the regions of the sky that are heavier, and red, these are the regions that are lighter. And in both of the maps, you can see a nice correlation with the blue regions in the galactic plane. Next slide, please. So how do we interpret these results? What do they mean? Well, first, and primarily, they're a very strong model-independent confirmation of a mixed composition above the ankle. And this is just because you can't get a composition anisotropy with a single component flux. They also kind of suggest that the galactic magnetic field might be having a stronger influence on our observations than we had previously thought. But it's important to note that this result currently is like 3.3 sigma, and that causal correlation between this result and the plane isn't really absolutely necessary. We'll keep studying it and try to figure out more about it. And then also, it shows that if you combine arrival direction with mass composition, on like an event-by-event basis, you're able to extract a lot of information about the ultra-high energy cosmic ray flux, and you can do it using the data that's already been taken or will be taken by this generation's observatories, which is excellent. And I have to say I'm excited because we're about to add event-by-event composition information to our SD via Auger Prime. And this will allow us to do high statistics studies of this type at the highest energies. And I'm really excited to see what we turn up. And with that, thank you.
Eric, thanks a lot. Very well done. Here's your prize. Will be posted to you as well, along with the mug.
I am looking forward to this mug. I have to really thank my collaboration. You've been both supportive and really given my analysis a lot of attention. This has been excellent. Particularly, I have to thank my editorial board. They gave me a huge amount of feedback, which really helped me polish the result in this presentation. And then lastly, I have to thank my local group in Wuppertal. You guys are absolutely excellent. And Karl-Heinz Kampert, he gave me the freedom to go after this kind of moonshot study, and it worked out, and I'm just very appreciative. Also, I'd like to thank all the participants who viewed my, my contribution and then asked me a lot of interesting questions. Thank you.
Well done, Eric. Thanks a lot. Then we move on to the next prize for best talk to Konstancja Satalecka, a postdoc of DESY and Zeuthen. And she did a contributed talk on searching for very high energy gamma ray emission associated with IceCube neutrino alerts using FACT, HES, MAGIC, and Veritas. And so we'll see if this works now. Konstancja was already on vacation when we caught her yesterday with the good news. Konstancja, please.
Hello, I think, David, it's better if you play the video. I'm sorry for this. My connection is very unstable.
Okay.
I get kicked out every few seconds. I'm sorry.
All right, no problem.
Hello, my name is Konstancja Satalecka, and it is my honor to present this collaborative contribution from FACT, IceCube, HES, MAGIC, and Veritas about the follow-up of neutrino alerts with imaging atmospheric Cherenkov telescopes. As you know, neutrinos and very high energy gamma rays should be produced together in hadronic and photohadronic interactions of cosmic rays. Therefore, joint gamma rays and neutrino observations help us to identify the potential electromagnetic counterparts to neutrino events and what follows the cosmic ray acceleration sites. This approach has already proven to be successful. In 2017, we identified the flaring gamma ray blazar TXS 0506 plus 056 as a potential neutrino emitter, following up a high energy neutrino alert from IceCube detector. In this talk, we present other follow-ups performed by Cherenkov telescopes after the IceCube 1709-22A event. The IceCube collaboration, operating the largest presently existing neutrino telescope on Earth, introduced several alert channels in order to inform the community to potentially interesting neutrino events and enable their follow-up and electromagnetic counterpart identification in real time. One of them are the single neutrino events with high probability of being of astrophysical origins. The events are publicly distributed via the AMON network, and all ISCTs participate in their follow-up. Our main goal here is to identify the electromagnetic counterpart to the detected neutrino event. Another channel are the neutrino multiplats or flares. In real time, an algorithm is looking for neutrino flares with duration from seconds to about half a year. Those flares can come from predefined list of sources, mostly AGN selected from the Fermilab and TEFCAT catalogs according to the variability, distance, and potential visibility for ISCTs. The alerts are distributed privately to the participating instruments. The ISCT goal is to detect the source in VHE gamma rays and determine the changes in the state of the source with respect to the previous observations. The same algorithm is also applied to the whole sky with the goal to find a neutrino flare emitted by a previously unknown source, or a source that is not on the list, and to catch, if possible, also its electromagnetic signal and identify it as a potential neutrino emitter. This sky map shows the directions of single events marked with crosses and the multiplets marked with diamonds observed by FACT in magenta, HES in orange, MAGIC in blue, and Veritas in green. From October 2017 until December 2020, IceCube sent 62 single event alerts. 11 were observed by at least one ISCT. No other sources were detected since the IceCube 1709-22A TXS 0506 detection in 2017. Since 2019, IceCube sent 27 multiplet alerts from 17 sources and one all-sky alert. 7 sources were observed by at least one ISCT. One source was detected by HES, but its flux at the end was at the same level as previously observed. A publication with detailed results from follow-up observations is coming soon. For now, I encourage you to have a look at the full talk recording and at the conference proceedings. Thank you for your attention.
Thanks, Constantia. This worked well now with the video. We were a bit nervous about this. So congratulations. Very well done. Here's your award. Yes, well done.
Thank you, David. Thanks to the organizers. Was an extremely pleasant surprise to get this prize. I am very honored to accept it, not only on my behalf, but first of all and foremost on the behalf of all the people who participated in the follow-up of neutrino alerts and everybody who contributed to this work. I am very happy that I have such good collaborators and that our work was rewarded in that way. Thank you.
Thanks. Well done. Moving on to our final prize recipient of today, of the Icrc 2021. Another award for best talk contribution is going to Nikolaos Karastatis. Nikolaos is a PhD student of KIT, Karlsruhe in Germany. And I do point out again that he had a talk that was presented in the presenter forum and has now got the opportunity to give us a speech about the content. Nikolaos, please.
Hi, thank you very much, David. Our contribution is about the radio module we developed in Corsica 8. Corsica 8 is a new framework for air shower simulations implemented in modern C++ 17. Its key features are modularity and flexibility. The radio module we designed and developed follows this philosophy as well and is integrated within Corsica 8. So it takes advantage of its very flexible environment and geometry and adds a radio process to the process sequence list of Corsica 8. Our design is aimed towards the current and next generation experiments. Its key features are its user configurable parameters, which are the track filter, the radio signal propagator, the formalism that does the radio emission calculation, and the antenna implementation. We have already implemented 2 propagators that use the straight ray approximation, 2 formalisms, namely the Koreas and the ZHS algorithms, and time domain antennas. Our design in Corsica 8 allows us to tackle limitation of the current state-of-the-art software, like implement sophisticated propagators that take into account reflected signals or upward-going showers, ray curvature, and showers crossing from air to dense media. Next slide, please. Having developed the module, we first performed low-level validation for both Koreas and ZHS algorithms in Corsica 8. We compared the signal pulse we simulated for an electron undergoing circular motion with a pulse arising from analytical calculation. Afterwards, we simulated a 10 TeV electron-induced vertical shower, and we compared our results with similar showers simulated using Corsica 7 and Xiris. Our first results are encouraging, and in this slide, you can see comparisons of the frequency spectra, radio pulses, and energy fluence maps. For the future, we aim to focus on fixing discrepancies and improve performance. We also want to implement more sophisticated radio signal propagators. This is a great time to reach out to us and join the effort so we can tailor the radio module to your specific experimental needs. You can find the Corsica 8 repository on our GitLab page shown at the bottom of the slide. Finally, me, Remy, Tim, and Juan, we want to thank you very, very much for your interest in Corsica 8 and radio in particular.
Congratulations, Nikolaos and the team for a very nice contribution. Well done.
Thank you very much for this award. Like, it is an honor, but we would also like to thank the rest of the Corsica 8 collaborators, because they also provided their expertise throughout these months to develop the module. And of course, we also want to thank everyone involved in this conference, because we recognize that it's extremely tough to make it happen with such success at such difficult times. So thanks, everyone.
Thanks a lot, Nikolaos. Greatly appreciated your positive feedback. All right. So everyone, virtually, the final round of applause for all of you, 7 prize winners. Impressive work. Now, of course, this is a proxy for a lot of other extremely good and excellent contributions that we've seen at this conference. And with this, we're basically done with our best contribution awards. We'll take a prize winner photo now, a screenshot. So I'll stop screen sharing. All of you guys, if you could enable your cameras again, and we'll do a gallery view photo screenshot. What was that, Jordan? ICRC? Everyone? Okay. So I think we did it now. And then I hand over to you, Sunil, for the final part of this year's ICRC, chaired by you as chairman of the C4.
Thank you, David. Okay, can you see my screen?
Yes, Sunil.
Okay. All right, so after 2 weeks of exciting presentations, discussions, and so on, we now have arrived at the closing session. But before I proceed, I would like to take this opportunity, and I think it is entirely appropriate to remember those colleagues whom we have lost in the last 2 years, but who could not be remembered in the opening session. I'm grateful to Agnieszka Gill from Poland and Stefan Kutu from United States for enabling us to pay these tributes to the colleagues we have lost during past 2 years. I would now like to show, it's a different slide. It's an older slide, which Johannes had presented during the concluding session of ICRC in Madison 2 years back. And at that time, we were hoping to come to Berlin and have a 1 week long conference. As you can see the dates from 15 to 22nd of July, but for obvious reasons, it did not happen. And Johannes had offered us all these enticements. We could see the wonderful culture, experience, the architecture, the science, etc. of Berlin, but pandemic put paid to all those hopes. And instead of sitting in Intercontinental Hotel, we are now meeting virtually. Well, that's what COVID-19 has done to us. And now we are having the conference being broadcast live through the ICRC Mission Control in Daisy Zeuthen. But I think there is no doubt, every participant, I believe, would agree that this has been an outstanding success. And the credit for that, of course, goes to the extraordinary efforts of the local organizing committee. And you can see the pictures of all of them. They are in all 30 members. But I have shown 3 of them. One could probably call them 3 musketeers in larger than life form, who have really made this a grand success. I'm not going to dwell too much on statistics, except to mention that having 1,800 participants from 55 countries represents an impressive 92% membership by IUPAP itself. So in that context, also it's a really successful story. As Johannes mentioned, we had more than 1,300 papers. Well, the number is 57 parallel discussion sessions, where about 50% of them were discussed, including question answer sessions. There were 2 presenter forums in lieu of posters. And thanks to this wonderful innovation, we have 7 winners from the presenter forums and parallel discussion sessions with us. We had a total of 51 plenary talks. And what I want to highlight here is that 41% of them were female colleagues. And that is well above the IUPAP guideline of 25%. So I think we have done that well on the gender basis also. There was one very successful public lecture in honor of Victor Hess yesterday. And of course, we had live streaming of all sessions with provision for interaction through question answer sessions, through virtual coffee breaks and so on. I do remember being an old timer, having attended ICRCs, which are 2 weeks long, but the last edition took place was the 25th ICRC in Durban in 1997. And after that, this is the first 2-week long, although virtual conference. Of course, we all know that since being the first experiment, there are lots of lessons to learn. And for that, a questionnaire has been circulated to do a survey of what your views are. So please take time and try to answer as many questions as comprehensively as you can, which will help us in planning things better in future. Now, proceedings, of course, of the contributed and invited presentations would appear in Proceedings of Science, and the deadlines, I just repeat, it's 31st July for the contributed papers and September 15 for the invited papers. And all these presentations in their full glory will be available on the ICRC 2021 webpage. And LOC has promised us that they will keep it going for the next 2 years, but I would strongly advise that we should visit it, because if the traffic were to fall very low, Johannes and David might decide to pull the plug and we will not have any more conferences. So please make sure that you do visit the conference pages as much as possible. At this moment, it is restricted to only the registered participants, but we had proposed, and LOC may consider opening it to a wider audience in due course. That is to be seen. The success of this conference is also due to the extraordinary efforts of the Ispcs, the International Scientific Program Committees, and I would like to take this opportunity to thank each of those committees. These committees were constituted through consultation with local organizing committee by the C4. We had made all-out efforts to select a representative sample with the balance in terms of discipline, regions of the world being represented, and of course, gender balance. So here is the first committee, the Ispc on cosmic ray indirect, and they carried the lion's share of burden in terms of 314 papers to review, led very ably by Karl-Heinz Kampert, and he was aided by another 7 outstanding colleagues. So congratulations, Karl-Heinz, for doing a fantastic job along with the colleagues. The second committee is the Ispc on gamma ray indirect measurements. They had to review 257 papers. It was very ably led by Jim Hinton and another 7 colleagues from across the world. And they too did a fantastic job. So congratulations, Jim and rest of the members of the committee. Ispc Neutrino was headed by Subir Sarkar, and they had the task of reviewing 221 papers. There were another 8 members who contributed to this task. And the final result is the proof that what an outstanding job they did. So congratulations to all of them. The fourth Ispc on cosmic ray direct was led by Elena Amato, and she was assisted by 6 other colleagues, and they handled 132 abstracts. doing an amazing job. Congratulations, Elena and colleagues. The Ispc on solar and heliospheric physics was led by my colleague on C4, Ilya Ososkin, who was assisted by another 6 colleagues, and they handled 127 abstracts. And this was also one of the highlights with many interesting reports being presented during this conference. So congratulations, Ilya and colleagues. The 6th Ispc on gamma ray direct was led by Luigi Tibaldo. He was assisted by another 7 colleagues, and they had to review 111 papers. And of course, they did an excellent job. So congratulations, Luigi and colleagues. Next, we have the Ispc on direct matter, and this was led by Fiorenza Donato, my colleague on C4. And this was a really lean committee with only 3 other members, and they handled 89 abstracts and did a fantastic job. So congratulations, Fiorenza and colleagues. And then the new stream, the Ispc on multi-messenger physics, which was led by Michael Kachelreis, my colleague on C4. He was assisted by another 4 colleagues, and they ended up handling 96 papers and did a fantastic job. So congratulations, Michael and colleagues. Now here I want to emphasize one thing, that not only the multi-messenger physics was a new stream, but it also necessitated close interaction between all the Ispcs, because cosmic ray direct, indirect, gamma rays direct, indirect, neutrino physics, dark matter, they all had overlap in terms of multi-messenger phenomena. So there was very good coordination between the chairs of all these 8 committees, and that is what led to these highly coherent discussion session format. So thanks are especially due to them, and also to the session coordinators, without which this would not have happened. And I think the opinion is unanimous that this was really one of the great innovations of this ICRC. And finally, we had the Ispc, which was constituted by the Local Organizing Committee on Outreach and Education, headed by Sabine Hammer and Carla Romo, and assisted by 4 other colleagues. And this was also, they came up with a very attractive program. So congratulations to them. Moving on, I would like to thank my colleagues on IUPAC Commission C4 on astroparticle physics, which also serves as the International Advisory Committee for the ICRC 2021. And the IAC worked very closely with the LOC. We had a large number of meetings. There were many times differences, which could be ironed out through discussions. And I am really grateful to my colleagues on the on C4 and IAC, because we had to call meetings on short notice. And as you can see from the composition, we have people from on the eastern side, from Japan to all the way to west coast of United States. So we had 16 time zones, not as many as those covered by the ICRC, but pretty close. And so it was always very inconvenient for some of them on the 2 extremes, but they rose to the occasion and gave their inputs. And you see, as an experimentalist, when we build an instrument, we always try to come up with a system with large redundancy. And I can confidently say here we had 16-fold redundancy. So because of the contribution of each of these members. Unfortunately, one of our very valuable members, Mikhail Panasiuk, passed away late last year. So we miss him. And till he was there, he contributed to every single aspect of the organization. Special thanks are to our outstanding people, such as the conveners of discussion sessions and presenter forum, the 32 highlight speakers who conveyed the exciting results in the key area of this conference, the 10 review speakers who covered the areas that are of general interest to the wider community, and the 9 rapporteur speakers who summarized the results from the 9 streams of the ICRC over the last 2 days. Now, a little bit of advertisement. we have some of the upcoming IUPEP sponsored conferences. The next one is Topics on Astroparticle and Underground Physics, TAUP, which will be held from 30th August to 3rd September this year, a month from now in Valencia in Spain. Then we have International Symposium on Very High Energy Cosmic Ray Interactions coming up next year from 4th to 8th of June in Ooty, India. And finally, the European Cosmic Ray Symposium, which will be held from 24th to 29th July 2022 in Nijmegen, Netherlands. Now, all three conferences actually are deferred conferences. They were supposed to be held earlier, but were postponed because of pandemic. TAUP is going to be virtual conference. Isvegri and ECRS, we are hoping, would be either in-person or hybrid conferences. But with this pandemic, it's hard to predict, as the experience of ICRC tells us. So we'll just keep our fingers crossed and cross the bridge when we reach. Now I want to draw your attention to a very important colleague, Professor Peter Kevgreeder. We are absolutely thrilled and delighted to have Peter Greeder from the University of Bern in Switzerland, a veteran cosmic ray physicist in our midst. With the exception of just one, Peter has attended every single ICRC in the last 56 years, starting with the 9th edition in London in 1965, when probably more than 70% of the attendees in this conference were not even born. And at 92, Peter is writing his third magnum opus entitled Ultra High Energy Hadron and Neutrino Astronomy in Astrophysics. Johannes, you talked about 12,000 pages for this conference. Peter's book is already more than 1,200 pages long. Peter, on behalf of the participants of this conference, may I wish you a very, very long life for the following reasons. A, you have to complete this book for the benefit of all of us present in this conference and those who would like to read it. B, you have to continue to inspire the next generation of cosmic ray physicists, young and old, such as myself. C, you have to allow us to celebrate your 100th birthday in 2029 during the 41st ICRC, wherever that might be. Okay, so this brings me closer to the conclusion. The next ICRC, the 30th edition, is going to be held in Osaka, Japan in 2023 from 26 July to 3rd of August. And now we have a message from the chair of the LOC, Professor Shoichi Ogio. It is in form of a video, which I will play now.
I am Shoichi Ogio from Osaka City University, and I am the chair of Local Organizing Committee of ICRC 2023. It is our great pleasure and honor to extend a warm welcome to all of you to the 38th International Cosmic Ray Conference, which will be held at Osaka International Convention Center in Osaka in Japan. Osaka is one of the biggest cities in Japan, located in the middle west of the main island. Osaka used to be the capital in the 7th century before moving to Nara and later Kyoto, and has been a commercial and cultural center throughout the history of this country. The main tower of the Osaka Castle is the iconic symbol and our heart of this city. People of Osaka are traditionally friendly and open-minded and love to please others. And also food is a defining characteristic of Osaka culture, and you can enjoy a volume of amazing and affordable food anywhere in the city. The venue of ICRC 2023 is Osaka International Convention Center. The International Convention Center is located in the center of Osaka City with hotels, restaurants, museums, art galleries, and other facilities. In addition, it is conveniently located with easy access to various public transportation systems, leading to downtown Osaka and nearby tourist attractions. The local organizing committee, the International Scientific Program Committee, and the International Advisory Committee jointly organize ICRC 2023. The main topics covered by this conference are cosmic ray physics, gamma ray astronomy, neutrino astronomy, dark matter physics, solar and heliospheric physics, multi-messenger astronomy, and an additional new topic in ICRC 2023 is gravitational wave astronomy. We hope that at the end of the conference, participants will feel that they have collected the latest information available in the field of astroparticle physics. We, the local organizing committee, are currently preparing to hold this international conference completely in person. And also, we would like to be able to accommodate participation from all over the world through the internet in some way. On your days off, please enjoy a travel to Osaka City or its suburbs. Osaka is surrounded by the sea and mountains. You will be able to enjoy the wonderful scenery and the rich nature within a short travel time. And also, Osaka is very close to Kyoto, Nara, Kobe, and Himeji. It would also be a wonderful idea to have a one-day trip to the historical cities or the modern, elegant metropolis. Finally, the members of the local organizing committee are very proud to host the ICRC 2023. Despite the current challenging situation of the COVID-19 pandemic, the local organizing committee is preparing to hold the international conference in person. We look forward to seeing you in Osaka in 2023.
Okay, thank you, Ogio-san. Okay, now it is my privilege and pleasure to announce that the 39th International Cosmic Ray Conference will be held in Geneva, Switzerland during July 15 to 24 in 2025. We have accepted the proposal of the chair of local organizing committee, Professor Roland Walter of Geneva University. Now, I don't have to tell much to you about Geneva, since Geneva is a well-known center of physics and of tourism. I think most people are aware of it. Anyway, we'll find out in 4 years of time. So, so I come to the final slide of this presentation. And now I revisit the ICRC survey. You would have received the email in your mailbox. Please try to answer as many questions as you can. This will be very helpful to our colleagues in Osaka in planning the online component and maybe even restructuring the way we organize ICRC in view of the lessons that have been learned. After all, this was the first experiment, and there are always chances that there are some things which would have worked extremely well and others which may not have. So your feedback is very crucial, and please give your feedback before the deadline. Now, I would like to take a minute to sort of revisit some of the takeaways from this conference by recalling some of the important highlights. The Parker Solar Probe and the Solar Orbiter are providing insights into our sun with high sensitivity and detail, which challenges our current understanding. However, if combined with ground-based muon and neutron measurements, they would offer a unique probe of the space weather. We had reports of new results on the properties of cosmic rays from the CALET, AMS, and DAMPE instruments, with multiple breaks in cosmic ray spectra and surprises in electron and positron measurements. Besides the cosmic ray composition, the AMS is also providing new insights into solar heliospheric phenomena. Gamma ray astronomy now has broken out from being the preserve of dedicated gamma ray detectors such as Fermi, Hawk, and imaging atmospheric Cherenkov telescopes to more traditional air shower arrays such as Tibet-AS Gamma and LASSO, which are extending the gamma ray measurements to hundreds of TeV and even PeV energies. LASSO has provided stunning measurements of gamma ray sources and cosmic ray spectrum with unprecedented sensitivity. The discovery of first pivotrons in the galaxy is just the flavor of things to follow in due course. At ultra-high energies, the Pierre Auger Observatory, the telescope array, are shrinking the systematic errors in their measurements beyond exielectron volt scale. And they have now been turned into all-purpose detectors by recording multitude of phenomena, including those of atmospheric and solar heliospheric origin. Fermi and other satellites are making new measurements of gamma ray bursts from magnetars and other extragalactic sources. The imaging Cherenkov telescopes too are discovering gamma ray burst afterglows at hundreds of GeVs. There are, of course, exciting measurements of neutrinos from giant detectors such as IceCube, GBD in Baikal, Antares KM3 at TeV, PeV energies, and phenomenal progress in expanding these and radio emission-based detectors in both the hemispheres are underway. Progress on phenomenology of particle acceleration in turbulent magnetic field, including diffusive shock acceleration from small to galactic scales, is being made to explain the new data. Progress was also reported in the understanding of high-energy hadronic interactions through simulations, modeling, and interpretation of data. Several reports were presented on dark matter searches by a number of experiments, and the phase space available for dark matter to exist is being continually shrunk. Finally, the blossoming of the multi-messenger physics, where the information is combined from a suite of instruments measuring gamma rays, cosmic rays, neutrinos, and so on, offers a totally new window on the highest energy processes occurring in our universe. There were also a number of reports on the new facilities on the anvil in almost every area that is covered by the Icrc. And despite its virtual nature, I believe that scientifically it was a great success with so many exciting discoveries and unexpected findings. Congratulations to all the participants for making the Icrc 2021 a grand success. During the annual meeting of the Executive Council of IUPAP and the chairs of 18 commissions representing different disciplines, each chair is usually asked to present a few highlights from their field. As the chair C4, I have the easiest of tasks. I start off by listing the sites of our experiments, ranging from deep underground, deep underwater, and under the polar ice cap, to the Earth's surface, to high mountains, and from there on to near Earth orbit, to deep space, and then on to interstellar space. This diversity of our experiments and their locales cannot be matched by anyone else. The physics we do is equally exciting, and this conference is a testimony of that. On a more somber note, the recent floods in Europe, including Germany and in Asia, have caused tragic loss of lives, as did the heat waves in North America and Africa. All of these disasters are suspected to be linked to global warming. And in that context, it is important to recognize that the precise measurements of various properties of oceans, polar ice caps, and of our atmosphere by the ongoing cosmic ray experiments and those that are planned offer invaluable new information on these key drivers of climate change. With this rather inadequate and biased summary, I now declare the 37th International Cosmic Ray Conference closed. Auf Wiedersehen. Osaka e yokoso okini. Welcome to Osaka. Thank you. And now, final goodbye from our hosts in Berlin.